This session is going to be network data analysis with Elasticsearch, Logstash, and Kibana, aka the Elk stack. The Elastic actually rebranded this into the Elk stack because I guess they felt Beats actually felt left out. So they actually rebranded this into the whole stack. So I'm going to use the two terms interchangeably because typically that's what the industry people do. They kind of say Elasticsearch and then they mean the whole stack. So just by a show of hands, how many of you have used Elasticsearch? Okay, so about 1/3. How many of you have actually extensive working relationship with Elasticsearch or Kibana or whatever? Okay, cool. So if I make any mistakes, please correct me, smack me on the head. So my name is Eric Chou. I work for A10 Networks. I'm a network engineering guy and been working in different capacities, and some of you may have known me through my book, Mastering Python Networking. I thank you if you have heard of it. If not, no problem. Now you have. So this talk is going to be going through kind of the when, what, who, and why, and then I'm going to have a demo. I think that's the most valuable part that you could see the sessions is just the demo, like see how it works. Talk is cheap. Show me the code. So what is Elasticsearch, Logstash, and Kibana? So these are open source bundle projects. So as you could see from the numerous logos, I mean, there's even more on the site. So these are all different open source projects kind of bundled in together. They work well with each other. However, they have boundaries. So they could actually take one part out. For example, if you don't like Kibana visualization, you could easily switch it out with Grafana. So that's very nice, right? Like when you start out with something, you want something that kind of just work. But when you're trying to, once it works, you want to optimize it for your own situation. So now you take out the different components of it. So the goal for the whole stack is actually, this directly from Elastic Code is take data from any source, any format, search, analyze, and visualize in real time. So that's a tall order, right? If you think about it, any format, any source, really? And you want to search and realize in real time? So it's kind of a dream to do that. So I would say it's whether you accomplish that or not, it's really up for debate. It's probably near real time if you think about it, right? Like nothing is real time. Everything we're looking at is after the fact. But that's their goal, and I think they come pretty darn close. But just keep in mind that's their goal. So out of all those different projects, there's really 4 main components of the Elastic Stack. So you have the search and analytical engine, that's the Elasticsearch part. You have the visualization, which is the Kibana. You have Logstash, that is the data input. And you have the newer beats. So in the beginning, they have Logstash, and then they have all these data that gets ingested, and then they transform it. They do kind of data enrichment in the middle, and then they output it to Elasticsearch. But that becomes really troublesome, and it becomes a lot of work to identify different sources, transform it, and so on. So the newer approach really is using beats, and there's lots of different beats. For example, you have the WinLog beats that just sits on optimized for Windows log. So then you don't have to worry about any kind of transformation, data enrichment. A large chunk is done for you. So really, that's kind of the newer approach for Elastic. So you have the analytics engine, that's kind of the central. You have the visualization, and then you have these 2 other components that handles the data ingestion, the data shippers. So search is so 1999, right? Like when you talk about, like, trust me, when I first started out trying to find the optimal backend for our data analysis backend, it didn't start with search, right? Like I kind of try some other stuff, and then we kind of fall back to it. So I guess we do have some millennials in the room. Like for the millennials, this is the Samuel L. Jackson, the director of S.H.I.E.L.D., but he just kind of looked a little bit different, right? So we want this guy, but we wouldn't want that guy. But what I'm saying is search really is kind of cool because, why do we want to use Elastic Stack? Because I think all of us will have questions in our mind, and we're trying to find answers from our data. So that's really the bottom line, is that we trying to answer business questions from our data, and the Elasticsearch allows us to do that. Here are the problems. We're swimming in data from different sources, and a lot of times we don't store them fast enough, and a lot of times we can't retrieve the information fast enough. And even if we retrieve the information, whether that's relevant or not, right? If you compare the search results from Yahoo and Google, then you know how important relevance is. Fast retrieval, relevancy, and different types of data sources. Those are the problems that we're trying to solve here. It's not that search is not cool, it's that we're trying to solve all these surrounding problems with search. And I'll come pretty close to that, like I said, in my opinion. And also is open source with commercial support. Elastic is a public company, so if you work for enterprise, you want some kind of SLA, you actually could buy commercial support, have a finger to point at if needed be. And also, because it's been around for a while, chances are the community is pretty strong. The problem that you encounter, that probably it's solved already. So all of these reasons are reasons to use the Alk stack, in my opinion. So why is the Alk stack relevant to networking? Because networking, by default, is the aggregation middle, and it's the messy middle. It's everything. How many of you have been pointed finger at because you can't find other problems, so networking must be the issue, right? I mean, I'm guilty of that. So networking is the aggregation middle, and it has different sources of data coming in that you have visibility toward. And the need to normalize different sources of data, it could come from logs, the flow, time series, SNMP, screen scraping, what have not. And you want near-time results, and the last two reasons that I think is relevant to networking are kind of my personal opinion, is there's no vendor lock-in, even though there's a commercial vendor, but it's open source. So the ceiling is pretty high for you to bump your head against if it even comes down to that. And again, I think the value of community cannot be understated. It's just awesome when you have a problem at midnight and you could find answers that somebody else already answered. So that's great. So where, when, and who? Like, who uses the Elastic Stack? And there's more logos on the site. Netflix, Stack Overflow, LinkedIn, and so a lot of major companies that you've heard of uses Elastic. And because of where we're at, I also point out the link that with the Cisco partnership. And of course, 810. This is our threat map, and if you go on that link, you can actually see it's actually real time. Every night we aggregate about 22 million or so documents on different types of malware, different sources, IP, organization, and so on. And if you're interested, I'm intimately familiar with how we constructed that map and the kind of frustration that I've hit for Elasticsearch, and just come talk to me afterwards if you're interested in hearing more about that. So how does this whole stack work together? So from here, you kind of want to look from the bottom up. So you have different sources of your data that could be routers, switches, or servers, and you could have beats that sits right on, like an agent that sits right on the server, right on the switch, and sends out information directly to Elasticsearch, or you could have the information get punted to Logstash, where the Logstash has a receiver, and then it transforms the data, enriches the data, send it to Elasticsearch, and then you visualize with Kibana. So the other open source projects that you see besides these four major components, sort of like application, like for security, for infrastructure analysis, or authorization-based access. So those are kind of just the add-ons. These are the four major components, and that's, you kind of read it from the bottom up and aggregates into Elasticsearch, and then you visualize it somehow. So here's an example of the ingestion. This is a Logstash configuration. So in this case, the transformation is skipped. You basically just have the input, which comes in from standard in, and then you have the output, which multiple streams are being dumped out. One is to the Elasticsearch. In this case, is the local host at 9200 port, and then you also have the standard out, which is displayed on your console, and then you run it through that command. And you could also do search through two different ways. You could have the URL directly. These two actually does the same thing. It's just that one kind of takes that information in the body, in the get API call. For those of you who have worked with REST APIs, so for a little bit, you probably threw up in your mouth a little bit when you see actually a request body in the get request. But technically it's not against the standard. So yeah, depends on your preference. If it really annoys you, use the first one. And of course, you do the visualization with Kibana. So that's the dashboard, or you could be like A10, our threat map. We actually uses our own JavaScript framework to construct our visualization, but on the back end is still Elasticsearch. So for further information, there's a few links, and if you're so interested, I'm trying to gauge the kind of interest out there. Like if you guys want to see another book on Elasticsearch, this is super early release, heavily discounted. It's $4.99 right now for me to just kind of get a sense of feel of if people are interested. If you do, appreciate the support. But let's get to the demo. So everything, all the information, I know I probably missed something, so I put everything on a GitHub repo as well as the background information. So if I miss anything, or if you felt something I wasn't explaining clearly, probably my fault. Feel free to hop onto this. And this one is the full video that you were just about to go over, and then you can also jump around into the different sections on just the lab topology, iOS configuration, NXOS configuration, Logstash configuration, and so on. So here's the demo, and I'm just gonna talk and skip around just because this is a 15-minute demo, and we probably just have 10 minutes. So we have 3 boxes, one NXOS, 2 iOS boxes, and this is basically just to do some verification and SSHing. I wanted to show the log configuration, goes out from the management interface, and the flow. iOS, very simple configuration, export the flows, and then on the interface, ingress and egress. And so this is a NXOS box, and as you know, NXOS supports NetFlow version 9. So this is configured a little bit differently. So of course the logging is similar, but by default it's through the management verb. And then so down here would be the flow export configuration. So let me skip ahead. And so in this case, in this lab, I actually installed the Elasticsearch and Kibana on the same host. So here I'm just showing that the daemons are running. So here, that was Elasticsearch, and now is Kibana. So depending on your flavor of Linux, you could install it differently. For me, easiest way just to download the Debian package, install it. And one thing I want to point out is that you don't want to mix and match versions. So if you use, say, in this case, I'm using 6.5.4 for everything. So you probably okay using version, say, 6.5.4 on Elasticsearch and 6.3 on Kibana, but 6 and 5, they don't match really well. So one thing that you probably want to be mindful of is just keep all the versions the same. And yeah, so here's the default interface for Kibana 5601. That is the port number, and to verify that it's up and running. So let's look at Logstash configuration and output. So now we have Elasticsearch, we have Kibana. Now we're ready to ingest the data in. And in this particular configuration, I also don't have any transformation data enrichment. I just have the input and output. In this case, I have the input opening up 2 UDP ports for iOS syslog, for NXOS syslog, as well as for NetFlow. So notice that I'm also tagging it with type. That becomes really important if you want to transform the data. You want to have like a if-else statement that says, if the type is this, I want to do X amount of transformation. Otherwise, do this. And in this case, I'm actually in the output. If it's NetFlow, I'm punting it to the Cisco NetFlow index. And if it's anything else, i.e. syslog, I'm punting it to the Cisco syslog. And notice the special formatting for the year, month, and day. So when you see the index creation, it will make more sense. So it will follow that format. And you use the Logstash binary reads the configuration, and off you go. So right here, also in the output, I don't know if you guys, if I pointed out, probably not, is I also use the output, the console output. This is great for debugging as well as for demonstration, that you could see in the raw format what kind of information is being punted to Elasticsearch, so that if something doesn't look right, then you could go back to the source and see whether that's Elasticsearch or the source. So because I punted to the console, you could see this is the flow record that's being punted to the Elasticsearch, and it's being indexed at real time, or near real time. So it's being put into Elasticsearch as it's being punted over. And in the next minute or so, I think I just want to generate some log. Yeah, I was waiting for a little bit. I don't see any log coming in, so I just decided to generate some log, come back to it and say, oh yeah, there's the log, and the Cisco iOS log, to make sure that the logs are, we could see the log later on in Kibana. Cool. So now that we have the information coming in, by default, Elasticsearch has of course, configuration file when you install Elasticsearch, but you could change this. By default, it actually allows you to create index as soon as the information is being received. So in this case, it's actually, the index is there, but Kibana is not aware of that index. So what we're going to do is we use the index management to make sure the NetFlow index are in there, the syslog index are in there, and we're using the index pattern to create that index. So I'm going to jump fast a little bit since I'm running out of time a little bit. So I'm creating the NetFlow, and if you notice, there's a wildcard at the end. So anything that matches, Cisco-syslog, and correspondingly the NetFlow syslog, the NetFlow start would match those indexes. So once that's in, you could see right away, you go to discovery, and you could start looking at the data that you receive. You could look at both the raw format as well as the JSON format for these records. And because we're interested in certain type of answer, so in this case, I just using 2 clicks, I was able to filter out everything that's NetFlow v5, and what you're left with is NetFlow v9. And the search string could get really complex, but in this case, it was a simple filter. And so I'm gonna speed fast through the few search string. What I'm trying to show here is just that once you're happy with the search, you can actually go to this panel, and then you get that request body, right away. You could just copy and paste. I don't know about you, but I could never come up with a request body precisely as the way that Elasticsearch wants. So for me, it's always easier to just visualize it first, get the result I want, and then go and check out what is the request body. And Kibana actually provides a good dev tools in order for you to test out, just even before you go offline, you calling the API, you can actually in the box itself and look at the results, and to make sure the request is good. So here is just using the terminal to look at the same request. So here's I'm tweaking the search parameters a little bit. There are lots of parameters I could tweak. In this case, I'm just using pretty print to instead of just jumbo text, I'm pretty print it so that the result looks a little more presentable. So once you have the data in, you could actually start visualize your data. And in this case, I'm creating a pie chart first, or donut chart with the empty middle, and I'm separating out for the terms and between NetFlow versions. So I'm between NetFlow versions, and you can see that it's displayed between 5 and 9 for the last 15 minutes of data. And you could save this visualization. And again, I'm using the bar graph. And in this case, this bar graph is differentiated between the amount of records from different sources. So remember, we have 3 routers. So now we have records from 3 different sources. And you could also save that. And once you've saved that, you could create a dashboard. So you create a new dashboard. I think I'm doing good on time. So you create a new dashboard, you add the dashboard, you search your saved visuals. For me, just these 2 visuals. And once you created your dashboard, you could actually embed it in your web app, or you could share it as a URL with somebody else. As long as they have authorization rights, they could look at it. And what I'm doing right here is just showing that it's real time, because even during the time that we're playing around with the dashboard, new data are coming in. So you actually change the time range, and you could get instant results from your dashboard. So that was it for the demonstration. We're good on time, so I don't think we have time for any questions, right? No. Okay, cool. So thanks again for being here. I appreciate your time. Thanks.